Hi all, Sammy here from Avid CNC. I'm really excited to share a recent event we got to participate in and to show you the workflow for the Grand Prix Pinewood Derby cars. So if you're interested in making your own CNC Pinewood Derby car, we're going to go through the whole CAD CAM and work holding workflow. I will set some timestamps so you can jump to that if you like. Otherwise, stick around for some amazing interviews and context for this larger project. Even if you're not into making CNC Pinewood Derby cars, I think that this workflow will still be very interesting because we're going to be focusing on production processes, efficient machining, and how it relates to CAD CAM workflows. All right, so now we're going to go talk to Tammy, the girly shop teacher, who helped organize this event in tandem with the Girl Scouts. And then we'll get to talk to two amazing designers who contributed to the project as well and designed a couple of the cars that we'll be making today. All right, let's do it. Hi, Tammy. Thanks so much for joining us today.
Oh, thank you for having me, Sammy. It's always awesome and incredible to work with you.
Awesome. So, everyone, I'd like you to meet Tammy, aka the girly shop teacher. So, I will definitely link to her website and Instagram below. So, be sure to check out and follow her amazing work. So, just a little bit of your background, and feel free to correct me if or add to any of this because you have quite the resume. So, you have your craft instructor certification from the National Center of Construction Education, which is really cool. I just learned that this means that all of your students have a lifetime certification in the trade, which is cool. You also were
Yeah,
recently on Disney Plus's new show, Shop Class, which now I
yeah.
have to go get my Disney. Well, not to do a plug on like my on the stream. And you work really hard to bring STEM and making learning and entering the trades more accessible. And you do it with such absolute joy. So can you just tell us a little bit more about you? And yeah.
Okay, so to piggyback off of what you said, I am a nationally certified trades instructor through the National Centers for Construction Education and Research, also known as NCCER. Their database is over 700,000 craft professionals from around the world.
Wow.
So if you are within the database and you are a craft professional and you're seeking employment, you can go to the database and find out where there's work. If you are a person who has a job offering, you can go in the database and request people to work because everyone's been trained and certified. So that particular certification system starts off with basic knowledge like tool safety, runs you through basic mathematics, the different power tools and their safeties, how to use them, and then it branches off into other skills, everything from frame up installations of windows and doors, roofing, plumbing, electrical, just to say a few, because I'm not going to name all the craft
Yeah.
titles, but that's just to say a few.
Yeah. That's awesome.
Yes. So my certification within that system is as a trades instructor for what is called building trades and construction through the Texas. Let me see, which one did I do? I did this is the craft
Hmm.
skills. You know, too many certifications, OSHA certified, college degree, all that stuff. It kind of gets wonky.
I know. I feel like you have to write a book. I'm here for it. So,
The book is actually started. Um, I have recently secured an illustrator because it is for a children's book, and the book's name is Love Letters to My Toolbox.
oh,
So now that I've put it out there, I actually have to finish
yes.
it.
Oh my gosh. I know. I just ordered Girls Garage and what's the other one? Another wonderful one as well.
Yes, I'm so excited about the work that Emily Pilton
Mhm.
does from Girls Garage. She has done such a magnanimous job in Berkeley, servicing all the young ladies that are there. They always have wonderful programs and projects that they work on. So it's always exciting to see someone else doing something similar
Yeah.
to what I do.
Yeah, and there's so many folks out there, and there were so many wonderful people you brought together for this event. So can you tell us a little bit about this event and kind of like what really brought us together?
So I have been working with the Girl Scouts of Northeast Texas for 4 years, doing the Grand Prix Race Day pre-workshop, which helps young people learn how to do woodworking techniques. We in previous years we would go on site with the girls and actually cut the cars live with the girls. But because we're in a different day and time, and we need not say why, because everybody knows, and we are wanting to make sure that students have all the experiences they possibly can, we decided that instead of canceling the Grand Prix race, we would do everything possible to make it virtual and make it what we call a semi-virtual event. So what we did was we had a pre-race workshop, which included the lovely Sammy of Avid CNC. Um, Sammy was able to talk about robotics and their role within the trades, and how you can use robots in order to manufacture 3D items. We had Cheryl Ash Simpson, who is an engineer and retired from Lockheed Martin and Rolls Royce. We had Kim of Relaunch Nail Polish, and she is a nail polish manufacturer. She specializes in small batch nail polish, and she talked about how different nail polishes influence the car industry and how you can use your nail polish in order to decorate your car because of the different weights of nail polish. We had Shar from Atlanta, Georgia. She goes by the Wooden Maven. She talked about wood burning and how you can customize your car and some of the traditions that come from wood burning, including laser engraving. We also had Pro Racer Will, who is a stunt driver. He's been in the movie Bad Boys and several other TV shows, including some stuff on, I think it was on TMC for Dolly Parton. He's a professionally trained stunt driver. And then we also had my lovely friend, Audrey Aronoff, who is a Disney Imagineer, and she got to talk about how assembly works because she's also an engineer. She and I actually met on the show Shop Class that we filmed a year ago before anybody knew what Disney Plus was.
Right.
So with our pre-race workshop, we were able to have all of these incredible people from all different walks of the building trades come in and hone in for the young ladies how their particular careers are represented inside of the building trades, and help them learn how to build their racers so that we're getting the aerodynamics, we're getting the proper weights, we're getting the speed, we're being able to get those cars down the track as fast as possible. So the young ladies were sent car kits. Some of them chose to cut their own cars from scratch at home. Other young ladies chose to design their cars and have us cut a custom car cut, which we did a few weeks ago. And yet other ladies chose to have the CNC machine cut one of 5 different racers, which were designed by the Avid CNC team and their wonderful collaboration of people. So that's what we have going on. And my team has been actively getting out all of those racers. Our race day is scheduled for November 21st. And it's going to be awesome and exciting because we've mailed the cars out to the young ladies, and we're just waiting for them to finish decorating them, send them back to us so they can race them and watch their race virtually. So that's the best we could do with social distancing, and we're hoping that the young ladies really love it. So far, the feedback has been completely amazing. Not just from the girls learning about the different techniques, but also them having some fun with other scout troops because they were able to do breakout groups from the platform that we use. So I guess that's a nutshell.
Yeah, no, thank you so much for that. I mean, I learned so much from so many of the wonderful folks you brought together, getting to learn from a race car driver and an entrepreneur and, engineers, a Disney engineer. Of course, there was such a wonderful group you brought together, and we're so honored to get to participate. We'll get to, in a few minutes, talk to two of the wonderful folks who contributed to our CNC car designs. And anyway, so Tammy, thank you so much for bringing us all together in a time where it's a lot of logistical challenges, but to have a day where they could get together to learn about design and aerodynamics and engineering, and then learn about how to cut cars or how to work with materials and safety, and then to receive their kits and then to be able to race them. I mean, what a wonderful way to kind of work around the challenges that we've been facing and to really bring these opportunities to kids, everywhere. So thank you, Tammy.
Well, thanks. Thanks. It was definitely my pleasure. And, we're looking forward to doing more events of a similar scope because we want to make sure that our young people have the opportunities to put their fingers on things because
Yeah.
there's something about the tactical aspect of learning that it's a void when kids are only able to utilize a computer. And so, especially with what you do, Sammy, kids are able to see the tactical part of
Hmm.
what happens when you can do great computer programming and then be able to touch the product at the end.
Yeah.
So kudos to you.
Thank you.
I love working on CNC machines myself. It's one of the great joys that I taught myself one spring break, and I am so happy that I know it now. And I just want to make sure that I share that with the next
Oh,
generation.
awesome. Well, next year, I hope we can cut some cars together then. Woo! Awesome. Thanks, Tammy.
You're welcome.
Bye. Well, welcome everyone. I wanted to introduce you to two of my friends who are also amazing makers and helped contribute to this project. So thank you both for making car designs that we were able to CNC and fabricate and send out to Girl Scouts all over the country. I just want to give you all a little bit of background on both of our makers today. First, we have Eileen, who is an amazing designer. You have a background in product design, and you've also managed a makerspace at a technical high school, which is so cool. That shop is awesome. And then now you're currently working for Fusion 360 support team. So definitely one of my good friends here I go to for lots of help when I need it. And I always appreciate it. You're also really passionate about different kinds of fabrication processes. I know you work with ceramics and soft goods and embroidery and all sorts of things. So I really love how you integrate all of those workflows into your practice. Do you want to
Yeah.
add any introduction about yourself?
Well, I'm Eileen. I grew up in Portland and I've always been a lover of arts. I've always considered myself a creative person and I kind of got into design through my love of art and got into digital fabrication through my love of art as well.
Awesome. Wonderful. And we also are joined by Alice from the Sparkle Cave, as I like to call it. Alice is a YouTuber, and I will link to her channel in the description below. So I hope you go check out all of her amazing builds after this. You are so amazing with all of your electronics and 3D printing and CNC machining. I would say you're also probably one of the best people at parametric modeling that I've ever seen. So if anybody's super interested in nerding out about parametric, go talk to Alice. Will you tell us a little bit about you and your background and kind of the things that you do?
Yeah. I really like just building the things that I need, and sometimes that's a longboard, and sometimes that's the tools to make a longboard. Yeah.
Solve problems. Yeah, I think
Yeah.
that's it's almost as fun, yeah, to make the tools, to make the thing, to figure out a way to make the specific object or product you're trying to um, achieve in the end, especially if that tool doesn't exist yet. um,
Yeah.
so I know that Eileen, you have made Pinewood Derby cars before, and you have experience with that. And Eileen, you have a lot of experience designing with product design, which you have the history of workflow and process of knowing how to solve problems and trying to figure out how to combine function and form. So I guess I'd like to ask both of you about what were the things that you would consider when designing for this particular project.
Yeah, well, I was considering a lot in terms of structure and durability. The design that I came up with has a lot of slots for storage and just having those materials taken away from the the car. I wanted to make sure that the walls were thick enough and make sure that there's enough spacing in between to keep up with how durable it is, making sure it's like not cutting too deep, just things like that. And I mean, did a lot of research on like looking at cars, wanted something that was functional and could hold weight.
Yeah, right, because you can add additional weight to your car in order to hit that weight class. You have to have your car between 4.5 and 5 ounces, and having those recessed areas already cut out for you definitely makes it easier. Alice, what did you kind of take from inspiration and from your, I know your previous history of participating in events like this, influence how you designed your car?
Yeah. As a Girl Guide, I had a lot of fun doing it. It was really my favorite part of the whole year. Um, and yeah, I guess I just sort of took everything that I sort of wanted to do back then, but didn't have the ability to do, and now we can do with awesome tools like CNC, and just started to have fun with it and shape it into something that looked really aerodynamic and sleek and really interesting. I ended up pulling up a whole bunch of different concept cars and not really following any of them, but just sort of appreciating the lines on them and coming up with something myself, you know,
Yeah,
inspired by those.
awesome. Well, that's wonderful to kind of hear how you would consider the engineering aspect of it, the aesthetics of it, and kind of, pre-existing forms that are out there that can help influence that. I guess I want to ask also both of you if there's anybody who is a kid, an adult, who's really interested into getting into digital fabrication, kind of what kind of advice you might give them as they're getting started.
I would say, at least the way that I learned and the way that I do learn is just, finding a good reputable program. I really love Fusion for this, and then just playing with all the different tools. Finding something that you want to make, having a starting goal in mind, and then just trying to figure out how how to use the tools to reflect sort of not just what you want to make, but who you are and how you
Mm-hmm.
think.
Say experiment and take lots of risks. It's easy to kind of, at least for me, when I was starting off in design, like getting stuck on like one idea and trying really hard to get that one idea to go through. But sometimes that one idea sparks other ideas, and really like the winning idea is something that you figure out after like 10 or 20 iterations. So
Right.
just take risks and experiment.
Right, and that's the great thing about digital fabrication. You can do many iterations that are just models or renders and practices in those elements of design. Um, I always call those translations, like a translation of a previous idea, and then that gets translated again and again, and kind of through that it becomes its own idea and its own concept. And I guess also, if you're interested in getting into these tools, I always like to think about uh, learning about understanding the process and kind of what a CNC machine or 3D printer, like what are the capabilities of it, and then designing within those limitations, Or, you know, if you're more of a, depending on which kind of camp you might come from a thought process to iteration, is you might be have an idea in which you want to make something particular, and then trying to break that apart and figure out how to fabricate it. So there's kind of the two processes. If you understand what the machines are capable of and then designing a project for that, versus having an idea and then figuring out how to make it. So kind of breaking down your ideas that way. Thank you both so much for joining me today, and I'm sure we'll all take your design advice into consideration in our future projects. So thanks so much.
Thank you, Sammy.
Yeah, of course.
Bye. All right, so let's get started by talking about work holding first. So work holding will affect exactly how you are able to machine your part, what parts, sides of the material you have access to, how strong it's going to be, how repeatable it is. So let's just dive into a little bit about how I might approach work holding for this project. So if you only have to cut, say, 10 cars, I might just go with the double-sided tape or foam tape or blue tape and super or CA glue method. If you are only doing 10 cars, then I say that would be just fine. If you're going to do somewhere around 30 to 50 cars, you know, I might make a jig, but a jig that might be disposable. So let's look at what that might look like. All right, so I have modeled this in Fusion, and this was just meant to be a temporary, quick, almost disposable jig. So this could just be made out of MDF or plywood, kind of whatever you have on hand at the time. So I just pocketed out a bunch of rectangles with dog bones here, so that the blocks could be easily inserted and then screwed in from the bottom. So this was a really great way to set up 30 blocks in set predefined locations that were easy to locate the jig, zero to the jig, and set the cam. The advantages here are that it's really fast and easy to make. Unfortunately, the disposable aspect of it is because the blocks have to be set below the surface. So if I set the block down in here, but I want to machine the full 5 sides of the block besides the one side that's being screwed and held against the surface of the jig, I might end up cutting into the jig, which will really make it difficult to have these walls as registration lines later on. So that's kind of why it's disposable, but it is a pretty quick and easy thing to do. So if you're making somewhere in the neighborhood of 50 cars, I feel like this is probably the way to go. Okay, so now let's go and look at our repeatable jigs. So Avid CNC has done a couple times where we have had mini maker fair events, which were pop-up booths where we brought a couple CNC machines and cut some Pinewood Derby cars for kids to make and race, which is super fun. But if we're making in the neighborhood of 1,000 cars or anything more than 100 cars, really, you'll want to have something that makes it really repeatable, easy to change out. And no, there's 2 different types of jigs that we made for this. And this was just going through a couple different iterations of the different maker fairs to try to refine that workflow. So this is just made out of HDPE, which is a perfect material for this. You just set your blocks on top and then either screw them in from the bottom or insert bolts from the top. So there are 2 different types of jigs here, and I'll show you the setup. We can either set the blocks on top that do not have any countersunk holes in it. I will just set a little bit of double-sided tape on the red surface, place the block on top, and then flip it over and screw them in from the bottom. These screws are in known locations, so when I design the car, I want to make sure that I'm not going to be hitting these screws when I do my cam. The other method would be to pre-counterbore and drill holes from the top surface of the block, and then we're able to put bolts through the block into the jig, into threaded inserts. So this is a really great method because you don't have to flip the jig over in order to remove the blocks. You can simply remove the bolts and switch out into new blocks, but it does take more time to prep the material ahead of time. So those are the 3 different methods I would reach for. If you're making 1 to 10 cars, I would reach for double-sided tape or the blue tape and CA glue method. If you're making between 10 and 100 cars, I might go for a more disposable MDF jig. And then finally, if you're making anywhere more than 100 cars, I would recommend making a really repeatable jig such as this HTPE method. I've linked to the files of the disposable and the repeatable HTPE jigs below. Okay, so now let's go ahead and talk about the different cars that we've made. So I'm just going to go through and show you these different designs. We won't go too much into the specific designs individually because I do want to share more on the CAM side of things. But we did give all of the cars really fun Girl Scout names, so if anybody was a Girl Scout, let us know if you recognize any of these references. So we have the Crazy Cookie Caravan, which was designed by Eileen Tran. Thank you, Eileen, for your contributions. This was definitely a popular design that was chosen. I think one of the really cool things is that when you make this car, you have to aim for a weight between 4.5 and 5 ounces. So sometimes you want to add additional weight to your car. These recesses here, these little seats, allow for additional weight to be added fairly easily. You don't have to recess another pocket for the extra weight to be added. We also have the Gordon Lowrider, which was also designed by Eileen. I liked this one as well because it did have a little bit more of that aerodynamic movement and also having a recessed area. We have the Jammin' Juliet, and this is one of the kind of original Avid designs that we've made at a couple different maker fairs. I remodeled it here for us to be easier to machine and easier for to use in Fusion. We also have the Trailblazer, which is, of course, a nice pickup truck for you woodworkers out there. This also has the great pocket in the back for the pickup for, you know, extra weight to be added later on. And lastly, we also have the Savannah Speed Racer, which was designed by Alice. And this was by far the most popular. I had to cut about 100 of them for this most recent event. And definitely very sleek and kind of a classic racer. So Savannah Speed Racer. Now let's go ahead and jump into the CAM setup. So when I start to approach a project like this, I really want to consider what my workflow is going to look like when I am the operator, the programmer, all at the same time. So when I am doing the CAM setup for 5 different car designs, I have to kind of really think about the workflow with different jig setups for different machines, different spindle capabilities for different feeds and speeds. So I was kind of juggling a lot of these different things, but it really helps when you have a project like this, even if it's a really fun project, especially when it's a really fun project, it makes it a lot easier to take that time to learn and to really practice refining those workflows. So let's dive into the CAM on the Trailblazer here. So as you can see, I have my truck nestled in here. And the reason I said that this jig is kind of more disposable is because if my router bit were to contact the jig to cut out the profile shape of something that was a little bit more formed than the truck, I might damage the pocket here, so then I wouldn't be able to re-register new fresh blocks. So with the Trailblazer, because it wasn't doing a profile, it was only doing machining on the top surface, it was a lot easier for me to preserve this jig for longer. So here I am going to show you the different toolpaths that I have set up. So I am going to go into this setup. I'll double click here. All right, so let's go ahead and jump into the Trailblazer setup here. So I'm going to go to Trailblazer and I will look at my setup here. So I have a milling operation I am looking at my work coordinate system. I want to zero to the jig. It'll be a lot easier for me to zero to the jig than to a block that I've set into the jig. So let's go ahead and look at what body I've selected. I've only selected one of the components, the first component, which is the truck here. I can also select the fixture if I'd like. And when I go to my stock, I've also modeled the blocks as well. So if you like to model your stock, that's something I really like to do. It really helps me visualize what I'm actually machining here. So I'll say okay. Okay, so now let's talk about what type of tool paths you might choose for something like this. So if you're cutting 1 to 10 cars, I might take a little bit more time and be a little bit more generous with the quality of the finish. So I might go for a 1/4 inch ball nose instead of a 1/2 inch ball nose. But when I'm really trying to machine 300 cars, I really need to be a little bit more particular about how much time is spent on each car. So the first one I did was an adaptive toolpath. So we're going to open this adaptive. And this was definitely more of a roughing toolpath. And for this particular setup, I just went with a 1/2 inch down spiral end mill. So it has a flat bottom. And I knew that I was going to have to do this smoothing pass on the surface of the hood of the car. But most of it, I really wanted the straight square edge here on the bottom of my pockets. So here I have selected the 1/2 inch flat white side, and I have my different feeds and speeds here. I have it about 250 inches per minute and ramp and plunge feed rate of 100 inches per minute. Let's go into the geometry. So here I just have the model selected, and I click include setup model. So that will just include the model that I've already selected in the setup. So that's all I need to do there. When I go to my different heights, I can inform it how deep I'd like it to cut if I wouldn't like it to go to any different surface, but go through and just hover over these so you can get a little bit more information on each setup. Now I'll go into my passes. So here is maybe where I might be particular about how much material I'm actually removing. So I have a 1/4 inch step down, which is my maximum roughing step down, which when I'm doing an adaptive, you know, I think that is definitely, we're using pine, which is super soft. I don't have to worry so much. So I'm just going to change my minimum step downs here to an 1/8 inch. I might even click this flat area detection so it really knows, oh, I need to refine this surface. This is a flat bed here. I need to clear up this edge. I can select stock to leave. I don't think that's super necessary here in this case. We just go through all our settings, double check, and then we'll go through our linking. We're just going to say this looks pretty good. I think one thing to note is exactly how often it will stay down or lift up. So I have that set to least, so I can try to reduce how often the router bit will lift up or the spindle will lift up. So we'll say okay. Okay, so I have a super rough tool path here, but it's really clean enough here for the truck bed as well as the lip around the truck bed and the top surface. So I'm really being left with this stepped preview here. So I want to make sure to clean that up. So I went with a parallel toolpath. So let's just open that up and check it out. So I have these surfaces selected, and I'm still going to stick with the 1/2 inch down spiral. And I have very similar settings. So we'll go over here to the geometry. I have the 3 faces selected. I might even be able to zoom in here and select my little radius. Perfect. And we'll go into our passes here and double check what those look like. I have adjusted my pass direction to be 90 degrees, which means that in this case, it will be going with the grain. And I will say okay. So here now we have our parallel toolpath, which is just going back and forth to clean this up. I've made this step over a little bit smaller just to make sure that that was clean and pretty easy for a scout to sand when they got their car. Okay, so now we have our toolpaths, but only for this first car. So as you can see here, I have 6 laid out currently because I have these patterned out in the design workspace. Okay, so now I have my 2 toolpaths here that are for my first car, but as you can see, I have 6 laid out here right now. I have in the design workspace, I just patterned the component. And so a really cool thing you can do, which is going to help with creating efficient layouts for something like this, is if you select your two toolpaths here and you right click and you go to add to new pattern. Here we can create a pattern with this particular toolpath. So I can go to pattern type and select component pattern, and then I will just select my source, which will be my original component, and it will detect any component that's been patterned off of that and automatically copy the toolpaths to those other components as well, which in this case is exactly what we want to do. So we'll say okay. Great. And now we have our patterned toolpath, and we're able to go ahead and post-process that. If I go back to the design workspace and I go back to edit this particular pattern here in these copies, I might also add, if I want to make a row back here, and let's make this 10. Here, I'll say okay. So now I have 30 cars laid out. If I go back into my manufacturer workspace, I can see that my toolpaths have automatically been patterned to all of the components that I have copied from our original Trailblazer. So now we can go ahead and post-process and load it up onto our machine. Okay, so let's talk about the cam for the Savannah Speed Racer, which is also super similar to the Jam and Juliet. So those ones are very kind of have a smooth surface, pretty round, and wasn't too difficult to plan. So let's go ahead and look at this. I have also patterned this toolpath as well, and we'll go look at this setup. So in this case, I have used 2 of my HTPE jigs, one in the back and one in the front, and I have another piece of MDF that I am temporarily attaching to my spoil board, and I've machined a pocket into this MDF plenum for me to place the jigs. So if I have 4 jigs, it's really easy for me to put 2 into the machine and then have 2 that I can prep and set up, and as soon as the cuts are done, I can switch them out really easily. I have a register for me to place these in as well. You can use some threaded inserts in the MDF plenum for you to bolt down the HDPE jigs if you like. So that really helped with the workflow to speed it up and have a couple of them going if you're going to be making quite a few of them. So let's go ahead and zoom in and look at this setup. So I have the this is the Jam and Juliet here. So we'll look at, we have the fixture that's selected. We have the stocks that's selected here. And we'll say, okay, great. So now let's go ahead and look at our toolpath. For this one in particular, I wanted to make sure that the profile itself, the contour, was cleared up. So there is the contour toolpath, which is just a basic 2D contour. So we'll open this up and we'll look here. I'm going to turn this off. We want to disable our coolant. And the other strategy here that I wanted to apply was to reduce the amount of tool changes. So I just went with a 1/2-inch ball nose so that it was extended just enough, but not too far past my brushes on my dust shoe, so that I can make sure to have maximum dust collection. And so I'll clean up, I'll kind of use the 2D contour as a roughing toolpath. It's not going to be too much on the surface of it, but to clean up this border of the profile of it. So here we'll go to the geometry, and I've selected this bottom contour here. And the heights here, the trick with the heights is that I didn't cut to the bottom of the car. In fact, I cut to this surface of the jig. So you can see that the car is sitting on top of a little ledge, and that ledge is where the car is used to register it to the jig. But I wanted it to cut into, it'll cut a little bit into this platform, but not too much, enough that I'm still able to register the cars fairly easily, but enough that that curved ball end of the bit would surpass the front edge of the car here. So if I'm going to cut out this profile, I wanted to make sure that that front tip wasn't curved. So you had to make sure to cut in a little bit deeper. So we'll say okay. And then we'll look into our parallel toolpath. So then I went with a parallel toolpath here, and I didn't even do a roughing toolpath. And this was with the 2.2 kilowatt. This worked really well on the 8.7 horsepower spindle as well. You know, really didn't have much to worry about in terms of material removal. So here I just went with a parallel toolpath, and I didn't have time for a roughing toolpath, so I just went straight for the finishing. So here we have the 1/2-inch ball nose, and we have our 200 inches per minute. I really actually ended up bumping that up to 250 when I was manually adjusting in Mach. And then in passes here, I think this might be kind of important. The step over I brought down to about a 32nd 0.03 inches. And the direction, I said it can cut both ways. I wasn't really worried if it was cutting one way or the other. Because the pine is pretty soft, it was going to be really easy material to remove. But these ended up coming out really super smooth and super nice. So I was happy with the results on this. Okay, so if we look at the Gordon Lowrider here, this is one that I didn't want to compromise too much on the finish here. So I did include a tool change here. So if I open this up, I first have my parallel toolpath, which was a roughing, but it was with the 1/2 inch bit here. So it didn't, I didn't want to do an adaptive. I just went straight for parallel and had that a lot of side cutting because it was removing quite a bit of material over here. So I went with the 1/2 inch tool there, and then I went for a finishing tool path here with a 1/4 inch ball nose. So lastly, I have the Crazy Cookie Caravan, and this one was a little bit more tricky to plan the cam because I wanted to make sure to get these little pockets down here. So when I first made the prototype, I went with a 1/4 inch ball nose for finishing and a 1/4 inch down spiral for adaptive clearing in here. But when I went into production, I ended up cutting with a 1/2 inch ball nose, and the seats had a little bit of a curve radius to them, and I ended up really liking that. The other challenge with this in particular was being sure that the screws wouldn't be hit by the toolpath. So I went ahead and modeled in the screws to make sure that they wouldn't be hit by the router bit, because that would be a no-go situation. So when I go back into my design workspace here, if I go to my bodies, and I go to the bodies, I can turn on pins, which are just the screws that I quickly modeled up in the locations that I knew that they would be in and exactly how far they would extend. So here you can see them highlighted, but when I click away, you can see that they aren't quite pictured here because they aren't sticking through, but I am still kind of risking hitting them here if they're not lining up too well. So let's go ahead and turn those pins on. So you can see here, they are below the deepest cut here, the deepest pocket. So we are safe. I think ideally if you're going to be making a bunch of different cars, you might have a set limit on how deep you want to pocket. But in this case, it worked out really well.